Hello everyone. In this video we will learn about trigonometric ratios of the angles which lie in the first quadrant. We have already learnt about the ASTC rule. According to that, we will find that the trigonometric ratios of all the angles which lie in the first quadrant will be all positive. So we find, suppose this is the quadrant system we are making, x, x dash, y, y dash, O, and suppose this is the initial position of the radius vector. When it moves in the anti-clockwise direction making the positive angle theta, suppose the position is this and P is the position OP is the length of the radius vector, suppose this length is R. If we draw a perpendicular from P to the initial position, that is PM, and consider that length of OM is X, length of PM is Y, then what we see? We will find here that OP, which is equal to R, will be in x square root of x square plus y square. And then we can find out the value of all trigonometric ratios of theta in terms of x, y and r. But now suppose this particular radius vector moves further and makes the angle 90 minus theta, then you will find that this is going like this and this will be the position OP dash of this radius vector, and this angle will be theta. Then only we can say this is 90 minus theta or not. In that case, if we draw a perpendicular from here to the initial position, that is suppose P dash M dash, in that case will you find these two triangles are congruent to each other? Why? Because this angle is theta, here this angle is also theta. This angle is 90 degree and here this angle is also 90 degree. And once these two triangles are congruent, we can certainly say in that case, in triangles OMP and triangle, see OMP we have taken, here we will have P dash M dash O, P dash M dash O. We find that O, that is angle O, or you can say angle theta, that is same as angle at this P dash. Also we find angle M is equal to angle M dash, they are both 90 degree. And also we find that OP is equal to OP dash. So do you find that they are congruent to each other? Two angles and one side. If they are congruent, therefore triangle OMP is congruent to triangle P dash M dash O. Then we can say that OM will be same as P dash M dash, and OM is X, so P dash M dash also will be X. Another side, PM will be same as OM dash, PM and OM dash, and that will be each Y. By CPCT we say corresponding parts of the congruent triangles. Then what we can see, suppose we want to find out the value of sine of 90 minus theta, that will be P dash M dash upon OP dash. P dash M dash is X, OP dash is R. And if you see from this triangle, X upon R is equal to cos theta. So the value of sine 90 minus theta is same as cos theta. If we go for cos of 90 minus theta, here it will be based upon hypotenuse, that is OM dash upon OP dash, and that will be y upon r, and y upon r in this case is same as sin theta. And similarly, when we go for tan 90 minus theta, tan 90 minus theta is perpendicular upon base. That will be here P dash M dash upon OM dash. What is P dash M dash? That is x, and this is y. In this triangle we see this x upon y is base upon perpendicular, which is cot theta. So tan 90 minus theta is equal to cot theta. And similarly, when we go for cot of 90 minus theta, we will find this is tan theta. When we go for sec of 90 minus theta, this will be same as cosec theta, and cosec of 90 minus theta will be same as sec theta. So we find these trigonometric ratios are all positive, and interchanging sign changes into cos, cos into sine, tan into cot, cot into tan, sec into cosec, and cosec into sec. This thing, if you remember, we have also learned while finding the trigonometric ratios for complementary angles. Let's learn now. See, when we have the angle theta, we have learned that this is P and perpendicular drawn to this is PM. This was R, this is X, and this is Y we have taken. Suppose this radius vector completes one of the round and comes back after this, makes one more angle theta. Do you find that this will be lying in the same position? We can see this is coming from here, making one round, adding one angle theta here, then you can say the same position of this radius vector will be lying in the same. So what we can say, when revolving line completes one or more complete rounds and goes further for angle theta in first quadrant, it will have same position as that of theta, and therefore we find that after 360 plus theta, the same trigonometrical ratios we will be finding as they are for theta. It means what? It means if we go for sine of 2n pi plus theta, or we say it as sine of 360 into n plus theta, that will be same as sine theta. There is no change. If we go for cos of 2n pi plus theta, or we call it in degrees cos of 360 n plus theta, that is same as cos theta. 10 2n pi plus theta, or in degrees that is tangent of 360 n plus theta, will be same as tan theta. Cot 2n pi plus theta, or we say cot of 360 n plus theta, will be same as cot theta. Sec 2n pi plus theta, or we say sec of 360 into n plus theta, will be same as sec theta. And cosec 2n pi plus theta, or in degrees we say cosec of 360 into n plus theta, is same as cosec theta. There is no change. Now if we put n is equal to 1 in these cases, then we find that sine of 2 pi plus theta, or we say sine of 360 plus theta is also same as sine theta, and so on. We can go cos of 2 pi plus theta or cos of 360 plus theta is equal to cos theta. Tan 2 pi plus theta is same as tan 360 plus theta in degrees, and this is also same as tan theta. Cot 2 pi plus theta or cot of 360 plus theta is same as cot theta. Sec 2 pi plus theta is equal to sec of 360 plus theta in degrees if we write, and that is same as sec theta. Cosec 2 pi plus theta is equal to cosec 360 plus theta is same as cosec theta. And likewise we can make the use of these formulae for finding the angles or trigonometric ratios for the angles which lie in the first quadrant. Thanks for watching my video. If you have any doubt or comments, leave them in the comment box and I'll get back to you.